contact with the extremely cold surface, my friend. Am I right? By the process of contact cooling, there is a process called as contact cooling. What is contact cooling? Am I right? Sometimes technically you call them as what? Conduction. Am I right? So very simple, my friend. By the process of contact cooling, right? Contact cooling, right? It results in what? Condensation, my friend, as simple as this, right? Subsiding air mass, right? Coming into an extremely cold surface. By the process of contact cooling results in on-ground condensation. See, how should I understand this contact cooling? I tell you. See, you take a bottle of water. See, for example, assume that this is a bottle of water. Am I right? So you just take this bottle of water, my friend, right from the fridge. Am I right? Very cold bottle of water. You just put it in the table, right? Once you put it on the table, you will find that after some time, water droplets will be formed, right, in the right. See, for example, outer surface. Correct? How? Because I understand contact cooling method. Every air mass will be having some moisture. There is no air mass in the world which is completely devoid of moisture. Some air mass, like some moisture will always there. So what happens? This moisture, when it comes into contact with extremely cold surface, my friend, right? That's the reason I said, by the process of conduction, you can call it as, or simply say, as a layman, by the process of contact cooling, right? It results in what? Condensation. All right. Now, what happens? The on-ground surface means on-ground objects, my friend. Whichever objects is there on ground, right? And this object should be cooled, right? It can be a plant, it can be a part of vehicles, particularly metals, my friend. Right? For example, if you have a metal, you'll be finding that water droplets, even if you park the means vehicles outside during this winter, my friend. Am I right? You'll be finding this water droplets forming. Particularly, that's it. Am I right? Okay. So that's what you call them as what? Dew drops. Okay. Now, somewhere I said during long winter nights, and what is very important here, it should be cloudless night. Very important, very, very important. Like cloudless nights. Why I am talking about cloudless night? Because if you have a cloud, say for example, assume that in night time you are having a cloud, correct? Terrestrial radiation will be reflected by cloud. If it is getting reflected by cloud, the terrestrial radiation, the heat will not be released, my friend. The heat is not released, the temperature will increase, my friend. So nighttime becomes warm if you have cloud. Am I right? So that's the reason I said it should be cloudless night. Very important. Okay. It should be a cloudless night. Okay. Right. So I talk about on-ground condensation. Somewhere, if you want to write it, all the essence you can write it, my friend. As I said. Already you have said, right? It is common during long winter nights, that too cloudless nights. Number one. Number two, you can write it. The subsiding air mass. Subsiding air mass. When it comes into contact with a cold surface, come on. By the process of contact cooling, results in on-ground condensation. By the process of contact cooling, results in on-ground condensation. Okay, right, my friends. So, what is on-ground condensation? We have an idea. See, all this ground object itself will be acting as the hygroscopic medium. That's it, my friend. Now here, what is a dew drop? When I talk about dew, dew is a water droplet, my friend. Water droplet. If that is the case, I should understand on what occasion dew will be formed if you ask me. My dear friends, dew will be formed when surface temperature, simple, right? NCERT has given so much of complex terms, right? But surface temperature, if it is more than 0 degrees centigrade, what you will have is a dew form, dew drops formation. On the other hand, if I just talk about frost, right? Frost is nothing but what? Ice crystal. process nothing but what? Ice crystal, right? On what occasion ice crystals will be formed? When surface temperature is less than or equal to 0 degrees centigrade, this ice crystal will be formed. That's it. Correct. Okay. Right, my friends. So, on what occasion dewdrops will be formed and what occasion frost will be formed? Somewhere we have an idea. Okay. It is not needed, my friend. Okay. On-ground condensation, if we have an understanding, now what we do, right? We just move on to the next type of condensation. What is the next type of condensation? We call them as what? Near ground condensation. Call them as what? Near ground condensation. See, when talk about near ground condensation, you call them as what? Either you call them as what? Fog, or you call them as what? Mist, my friend. Alright. What is this fog or mist, my friend? Simple definition. Right, simple definition as a layman, if you ask me. Fog or mist is nothing but what? A near ground cloud. It's nothing but what? A near ground cloud. This is what I call them as fog or mist. Right? It's nothing but what? A near ground cloud. Right? See, what is mist? See, technically they say fog and mist, they are technically different. Of course, yes, I do accept. Right? I accept. But in simplicity, we can see always I believe that normally we say, right? Simplicity is a beauty. Right? Simplicity, as simple as it is possible, even in mains examination answer writing, if you are going for simple sentence formation, right? Even the examiner who's correcting the paper will also means your evaluator will start understanding your language. I mean, it is very easy to understand. Okay. That's the reason I say simplicity is a beauty, my friend. In that regard, if you ask me, what is the difference between fog and mist? I would say less dense fog is mist. Simple. Right? That's the reason if you ask me, right, slightly, see, technically it may not be, but still let me tell you, my friend, if you ask me what is mist, mist is nothing but what? Less dense fog. Less dense fog, you call them as what? Mist. That's it. Alright. Now, my friend, fog or mist, I call them as what? Near ground cloud. So, where exactly I can show the difference? Visibility. Normally, when I talk about visibility, right? When I talk about fog, my friend, fog. The visibility is less than 1 kilometer, my friend. You call them what? Fog. Then on condition like mist, when the visibility, right, is between 1 to 2 kilometers, okay. People who may not understand my shortcuts, okay. When the visibility right is 1 to 2 kilometers. You call them as what? Mist. As simple. More than that, you don't call it by any name. Okay, that's it. As simple as this. Right. Right, my friends. So, less dense fog, you call them as mist. Okay. So, somewhere you can differentiate them based on the visibility. Right. You call them as what? Fog and mist. As simple as this. Now, when I talk about fog, my friend, there are plenty of types of fog. Right? Types of plenty are there, my friend. Plenty of fogs are there. Right? So what are the types of fog, if you ask me? Normally, NCERT has given 4 types of fog, but I will bring only 3 types of fog. NCERT has also given a type of fog called as precipitational fog. So I am somewhere leaving this precipitational fog, only the major fog I am just bringing. What are they? Number 1, I call them as what? A radiational fog. Radiational fog. So what is this radiational fog? That fog which is common during lower latitudinal winters, my friend. Right? Lower latitudinal winters. So, I talk about radiational fog, it is common during lower latitudinal winters, my friend. See, even we normally, right, in the month of January, my friend, Margary, right, we'll be experiencing this fog, correct? But morning 2 o'clock, 3 o'clock, we'll be experiencing the fog, right? And this fog, whenever the air mass subsides, right, this also brings cloud along with it. Okay. It will occupy the surface, right? You call them as what? Fog. Okay. Now what happens only when the next day sun comes, only if it is heating up this region, right, this fog will get cleared. Otherwise, wind should blow. Okay. If at all, if you have a wind, this wind will also take the fog away. Am I right? If you don't have wind, the only mechanism which can remove the fog is what? Sun, bright sun. Only when the sun shines bright, am I right? Again, it will get heated up, it will go high in the sky. Otherwise, fog will not get cleared. Okay. So what we experience is what is radiational fog. Am I right? Apart from this radiational fog, we also experience what? Something called as what? Like advectional fog. Advectional fog. So where exactly you experience this advectional fog, if you ask me, it is common in Western Europe, my friend. Western Europe, to be very precise, right? United Kingdom or Britain. Right? Britain is very, very common, my friend. Right? Britain. Right? United Kingdom, or you call them as what? Britain. Okay. Great Britain, Britain, whatever it is. Just a minute. Right, my friends. Now here, we're talking about the types of fog. How about types of fog? Right? Radiational fog and advectional fog we are just discussing about. We're talking about this advectional fog. Somewhere I said, right? Britain, my friend. Right? Britain or United Kingdom. You call them as a Great Britain, am I right? Right. Or simply you call them as what? United Kingdom, whatever it is. Right. So this is a place where you experience what this advectional fog. Okay. Right. Apart from this advectional fog, if you ask me what are the other types of fog experience, right? Apart from advectional fog, you also have a fog called as frontal fog. Frontal fog, my friend. Okay. So I talk about this frontal fog. Right, this frontal fog we experience along this mid-latitudes, my friend. Mid-latitudes. Or say, for example, assume, right, if you say mid-latitudes or somewhere around this 60-degree north and south, my friend. Right, where you have a pressure system called as subpolar low, this is the place where you have this frontal fog. All right. Only 3 types of fog, it is better, right? We know only these 3 types of fog. Where exactly this is prevalent, that is fine enough. Okay. So what is on-ground condensation? What is near-ground condensation? We have taken. And my friend, the most important one is atmospheric condensation. This atmospheric condensation, we call them as what? Cloud. Okay. We call them as cloud. Okay. This is the commonest form of condensation, my friend. Right? This is the commonest form of condensation. Somewhere you can write it. It's the most commonest form of condensation. Right? It's the most commonest form of condensation. Right? Now, my dear friends, I would like, means, if at all if possible, kindly take the definition of a cloud. What is given by WMO, my friend, World Meteorological Organization, has given the basic definition of a cloud. Right? So that somewhere you write the definition of a cloud. Very important. So that you will understand. See, most of us, that's the reason I said most of us think that cloud is nothing but what water vapor. No. See, water vapor is a gas and water vapor is transparent everywhere, even within the room where I am sitting is full of water vapor. Correct, but you cannot see it. It's a gas. Correct. Cloud is not gas, my friend. Cloud is the aggregate of water droplets, or it is an aggregate of what? Ice crystals, my friend. Right? So somewhere, kindly take the definition. Cloud. The visible aggregates, you can write it, cloud is a visible aggregate of a tiny ice crystals, and minute water droplets. See the definition, it says, cloud is a visible aggregate of tiny ice crystal and minute water droplet. Okay. And a minute water droplet. Okay. It means what? Cloud is full of small water droplets and very tiny ice crystals. That's it. Okay. Now, my dear friends, post understanding the cloud as a definition, the only thing is that we have to classify this cloud. Alright. So, my dear friends, when I talk about cloud, how exactly you can classify this cloud, I'll tell you. Different ways, my friend. Clouds can be classified. Say, for example, clouds can be classified based on shape. Right? Cloud can be classified based on height. Cloud can also be classified based on weather effectivity, my friend. Right, so there are different ways how exactly you can classify this cloud. I'll tell you one by one. Based on shape, if you're just defining or classifying the cloud, my friend, three ways you can classify. Number one, we call them as what? Cumulus clouds, my friend. Cumulus cloud. So how exactly this cumulus cloud will look like, my friend? It almost resembles what? A globular mass. Right, see, this is the commonest representation, what we take it for, what representing a cloud. Globulus. Right, globular mass, my friend. Right, it is more of what? Globular mass. Right, globular mass. Cumulus. The commonest, when I say cloud, this is the image, what exactly comes in front of me. Right? Commonest type of cloud is what? Cumulus cloud. Number two, what I have is a stratus cloud, my friend. Stratus cloud. See, stratus cloud is more horizontal in extension, my friend. Right? It is more horizontal in extension. Okay. It means almost it extends more like a sheet-like structure, my friend. Right? It extends more horizontal in nature. It extends more sheet-like structure. I'll also bring the original image of it. Okay. It is more like a sheet-like structure. I'll write it. It is more like a sheet-like structure. More horizontal in nature. There's a sheet-like structure. See, cumulus cloud is vertical cloud. Stratus cloud is a horizontal cloud. Alright. It spreads like a sheet. The third category of cloud, my friend, we call them as what? Cirrus cloud. We call them as what? Cirrus cloud. See, cirrus cloud is a very thin, fibrous cloud, my friend. The very thin, fibrous cloud. You call them as what? Cirrus cloud. So these are the three types of cloud, what it is based on shape. On the other hand, if you ask about height-based classification, simple, based on height, we call them as what? Low altitudinal cloud. Low altitudinal cloud. What is this low altitudinal cloud? All that cloud which has a height of less than 2.5 kilometers. Height. You call them as what? Low altitudinal cloud. Number two is what? A mid altitudinal cloud, my friend. You call them as what? Mid altitudinal cloud. All that cloud which extends between 2.5 kilometer to 6 kilometers in height. in the troposphere. You call them as what? Mid-altitudinal cloud. Number 3, we call them as what? High-altitudinal cloud. You call them as what? High-altitudinal cloud. So what is this high-altitudinal cloud? All the cloud which has the height of more than 6 kilometers, we call them as what? High-altitudinal cloud. Correct? Right. So the 3 types of cloud we have seen, right? High altitude, mid altitude, and low altitude. And finally, my friend, based on weather effectivity, correct? Number 1, you call them as what? Fair weather cloud. Fair weather cloud. So what is this fair weather cloud? Cloud will be there, but this cloud will not result in precipitation. Oh, precipitation. If you are just looking outside your window now, right? Somewhere high in the sky, you will be finding some cloud, right? Floating and say, for example, drifting along the wind, correct? But it will not precipitate. That cloud, you call them as what? Fair weather cloud. Cloud will be there, but no precipitation, passing cloud. Okay. Number 2, my friend, rain-bearing cloud. Name itself says rain-bearing cloud. Right? So rain-bearing cloud means what? Those clouds will result in precipitation. You call them as what? Rain-bearing cloud. Okay. And comes the 3rd cloud, bad weather cloud. Call them as what? Bad weather cloud. So what is this bad weather cloud, my friend? It is nothing but what? Intensified rain-bearing cloud. It's intensified rain-bearing cloud. Okay. This bad weather cloud is very popularly called as nimbus clouds, my friend. Very popularly called as what? Nimbus clouds. Correct? See, what is a bad weather cloud? See, how? I'll tell you, whenever I talk about bad weather, my friend, what is a bad weather? Right. Say, for example, a cloud which results in what? Very heavy precipitation, right? Right? Very heavy precipitation. Heavy precipitation. Correct. This heavy precipitation, sometimes you call them as what? Torrential rain. Call them as what? Torrential rainfall. Am I right? Sometimes it also becomes an example of what? Right? If you remember, there is one term called as what? Cloud burst. Right? Cloud burst. Very heavy precipitation in less span of time, you call them as what? Clouds. Okay. I'm just giving you an example of how a cloud can become a bad weather. Right? Very heavy precipitation. Number 2, my friend, lightning and thunder. Lightning and thunderstorms, my friend. Lightning and thunder. Which cloud will be resulting in lightning and thunder? Bad weather cloud. This bad weather cloud is the one, very popularly you call them as what? Nimbus clouds, my friend. Call them as what? Nimbus clouds. Okay. You call them as a nimbus cloud. Bad weather. Apart from this lightning and thunder, what are the other bad weather means you can have associated with the cloud, my friend? Yeah. You heard about this hailstorm, right? Right, you heard about this hailstorm. See, every now and then, you cannot experience only the water droplet and small tiny ice crystal which is falling from the cloud. Sometimes, my friend, you may have what? A very large ice crystal which is falling from the cloud. This very large ice crystal which is falling from the cloud. You call them as what? Hailstorm, my friend. See, sometimes, let me tell you, what you are seeing here is actually a hailstorm. It's a hail. Right? See how big this hail is, my friend. I have just copy and paste it for your. See the hail. See the size of the hail, my friend. Right? That's what I call them as hail. Most of the time, people means take this for what? Like people almost, say for example, treated, they feel as though it's a golf ball, my friend. It's not a golf ball. It is hail. Large chunk of ice which is falling from the sky, you call them as hail, my friend. Hail is very, very destructive in nature. Right? It is destructive to the catalyst, right? Property, see how it can break open the windshield of your car also, right? Very dangerous. It is very, very dangerous, right? Sometimes it becomes fatal also, right? Right. So, somewhere. What is a bad weather? Somewhere I have an idea. Okay, so I have just given you the basis of classification of this cloud weather. Now, most of the places, any places you take it, what is that it is highlighted? I'll tell you, these are the common names which is highlighted. People will be talking about cumulus, people will be talking about stratus, people will be talking about cirrus, and straight away they will be talking about nimbus. Okay, these are the four basic clouds what we have. Okay, see, nimbus itself is not a separate cloud, my friend. Only these clouds on intensification, it becomes what nimbus. So if at all I'm just putting it as a types of clouds, types of cloud, right? Majorly four. Further, if you're just going for a combination, right, it becomes 10, my dear friends. 10 different types of cloud we have. So if you ask me what are the four major types of cloud, see the cumulus cloud, what I said, it is vertical cloud or like a globular mass. Cirrus cloud, fibrous clouds. Stratus cloud, more like a sheet. Nimbus cloud is a dark cloud, right? You call it as Karmegam, right? Karmegam. In the you call it as what? Kal Mega, right? Kal Baisakhi, right? So it means very dark cloud, you call them about nimbus cloud. Why it is dark? Because it is so thick, it will not allow the sun's rays to surpass or penetrate. That's the reason you call them about dark cloud. See, only looking at the same cumulonimbus cloud or nimbus cloud, if you're looking from the flight, my friend, it will not be dark. Only looking from the surface of the earth, it will look dark in nature. Okay, right. So what are the major four types of cloud we have? And my dear friends, let me also show you what are the 10 major types of cloud. Okay, 10 major type of cloud, my friend. There's a 10 major type of cloud. When I talk about the major types of cloud, completely what we have is what? 10 different types of cloud, my friend. Okay, right. Somewhere, I think that you can see it. See, the values may slightly change. See, you know, based on height, we have classified the cloud into, right, different types, my friend. Okay, say for example, low altitudinal cloud, right? Mid altitudinal cloud, mid altitudinal cloud, and high altitudinal cloud. Okay. Low, mid, and high altitudinal cloud method. And approximately, I am just marking the height also. Okay, approximately, I am just marking the height. Okay. So, see, that may not exactly replicate what exactly is the height what we have taken it, but just to tell you, right, what is the basis on which we are almost classifying this clouds, okay, based on height. Then, my dear friends, based on shape, we have taken three. Am I right? What are they? Right, you have cumulus, right, you have cumulus cloud. Then you have stratus cloud. Then you have what? Cirrus cloud. And based on weather effectivity, my friend, we have another type of cloud. What do you call them as what? Nimbus clouds. Okay. So all these clouds, right, what I understand, right, their combination makes 10 different types of cloud. Even if you want to remember this combination, actually this combination is very easy. I'll tell you how. See how you can remember it. How you can remember it, let me tell you, my friend. See, the cirrus cloud always you find in higher altitude. And nimbus cloud always you find it in what? Lower altitude. See, forget about the extension of this cloud. You take only the place where the base of the cloud is located. Okay. In that regard, my friend, right? Nimbus cloud is always associated with lower altitude, and cirrus cloud is always associated with higher altitude. That's the reason. Cirrus and nimbus, they don't form a combination, right? Combination. That's the reason normally I used to say, somebody is asking you why polar bear will not feed on penguin, my friend. Polar bear is also confined to the polar region. Penguin is also confined to the polar region. Polar bear is a carnivore. Why exactly this polar bear is not hunting penguin? If you ask me, the reason is very simple. Because polar bear is confined to Arctic region, North Pole, right, or North Polar region. Penguins are confined to what? Antarctica. Just to have a penguin, it cannot cross equator. Am I right? Okay. So that's the idea, my friend. See, that's the reason. See, they don't go for a combination. The place of its existence is different. Now, my friend, see, otherwise, all cirrus cloud is confined to the higher altitude. See the cirrus, independent cirrus combining with stratus, cirrostratus. Cirrus combining with cumulus, cirrocumulus. Okay. All cirrus over. What we have is only cumulus and stratus. Mid-altitude. Cumulus with the word called as alto, it becomes alto-cumulus. Stratus with the prefix called as alto, again it becomes what? Alto-stratus. Right. Only cumulus and stratus, but with the word called as alto. Right. Now, my dear friends, if you're there in lower altitude, where I also have nimbus, see the beauty. Cumulus intensified cumulonimbus. Stratus intensified illostratus. And cumulus and stratus going for a combination. All 10 types, if you want to remember, you can very easily remember. Right? There is no hard and fast rule. Right? Very easily you can remember. Okay. But however, for examination purpose, if you ask me, which cloud is very important? Am I right? This cumulonimbus cloud is important, my friends. Can you find this cumulonimbus cloud? This cloud is important, right? So what we do, we'll talk only about cumulonimbus cloud, my friend. All of a sudden, you will not have cumulus cloud being formed or cumulonimbus being formed, my friend. What happened? Only this cumulus cloud, over a period of time, it becomes what? Cumulonimbus cloud, my friend. Right? Assume that you have a cumulus cloud, and cumulus cloud over a period of time becomes what? Cumulonimbus clouds. Becomes cumulonimbus. This cumulonimbus cloud, often you call them as what? A towering cloud, my friend. This is also called as, most of the time you call them what? A towering cloud. You call them as a towering cloud. Why? It looks like a tower, as simple as this. Sometimes they also call them as what? Multi-altitudinal cloud. And again, I'm going to repeat it. Only cumulus cloud, over a period of time, it becomes what? Cumulonimbus cloud. How and why, if you ask me? A strong vertical movement within the cloud. Very strong vertical. Right? Right? Very strong vertical movement. Right? You ask me, what is a very strong vertical movement? If the air mass is rising, if the particles are rising within the cloud, you call them as what? Updraft. If particles are falling with the effect of gravity, we call them as what? Downdraft. Right? Every instance, right? Every instance, my friend, this updraft is important. Right? What happens? The size of this ice crystal. See, cumulonimbus cloud is the one which results in what? Hailstorm. My friend, hail. If you ask me hail, which cloud results in hail? It is cumulonimbus. Very important. Something I wanted down, my friend. This is the one which is known for what? Hailstorm. This is the one which is known for what? Nimbus itself means what? Bad weather cloud. Okay. Now comes the question. Everything is fine. But why? Why this cumulus cloud is becoming cumulonimbus cloud? It's all because of what? A very strong rising convection. Wherever you experience a strong rising convection, right? If you experience a very strong rising convection, you all experience what? Cumulus clouds becoming cumulonimbus cloud. There you will be having a strong rising convection. This is another question, my friend. Normally we say wherever you have a warm region, right? Wherever you have a warm region, there all you experience what? Strong rising convection. As simple as this. Okay. So my dear friends, cumulonimbus cloud you will not find everywhere. Cumulonimbus cloud is actually confined to the warmer latitude. Which region will have hailstorm? Hailstorm is very, very big chunk of ice falling. Alright, you will not have this ice chunk falling in temperate region. This ice chunk will be falling in what? Tropical and equatorial region, my friend. Why? Warm region. Right? And finally, my friend, if I am there in cumulonimbus cloud, normally you will be finding that this cloud on reaching the tropopause level normally gets deflected towards eastern side. The structure, very popularly, we call them as what? Unbuilt fog. We call them as what? Unbuilt fog. If you ask me why this part of the cloud is getting extended towards east, if you ask me, it's all because of what? Jet stream, my friend. It's all because of jet stream. Because I know the direction of the jet stream, right? Where exactly from where to where jet stream flows, from west to east. Right? While doing so, it also takes this, right, almost, it results in the extension of this cloud towards the eastern side. Okay. Somewhere, dissipating stage, you can leave it. Right? You can leave the dissipating stage. But see a very close look, my friend. How this cumulus cloud over the period of time becoming cumulonimbus cloud. Right? Life cycle. Then at one point of time it should dissipate. Okay, there is no denial about it. But understanding says, as I was saying earlier, only cumulus cloud will eventually become what? Cumulonimbus cloud. This is stage by stage development. Okay. Somewhere I'll copy this image. So any cumulus cloud, you take it, right? Any cumulus cloud, you take it, my friend. Okay. So normally what happens, whoever has drawn it, very good, right? Updraft, downdraft, right? And you will be having an extension of this towards the eastern side, very good. But this image is a good image, right? Whoever has done it, right? And the moves. Okay. Stage by stage, how exactly, right, it forms. Even the dissipating stage, I'm just removing it. Okay. Actually, it is not needed for us. Right? Only these two stages. The rest of the stage, it is more than enough for us. Okay, right. So, only things that I was talking about how exactly this cumulonimbus cloud, right, slowly, steadily goes for a formation. Okay. The only thing is that some of the popular images that is there on the net, they're utilizing it. Okay. Same thing we are just also discussing about it. So, how exactly one cumulus cloud eventually becomes cumulonimbus cloud, right? That's what we have been discussing, right? So everything is fine. Okay. All the bad weather effectivity, what we normally discuss about, right? This is actually associated with this cumulonimbus clouds. Okay, right. Now, all the type of cloud we are not so much interested in, but only this cumulonimbus cloud we are interested in. Okay, right, my friends. And finally, if I just talk about condensation, also we have done it, right? And finally, when I talk about precipitation, my friend, the last cycle, right? Last cycle, my friend, precipitation. Precipitation is the last compartment in the cycle of hydrological cycle. This is hydrological cycle. What is precipitation, if you ask me? Right. Somewhere you can write it. So everywhere you have the word called as fall, rainfall, snowfall, right? Something like that. So why exactly it is falling, if you ask me? It is all the effectivity of gravity. Right? So all the effectivity of gravity. So my friends, somewhere you can write the basic definition of precipitation. What is precipitation? Somewhere you can write it. The gravity fall, I repeat, the gravity fall, I'll write it along with you better. The gravity fall of condensed material from the base of the cloud, is called as precipitation, right? I repeat again, gravity fall of the condensed material from the base of the cloud is called as precipitation. That's the reason, sarcastically I used to say, anything which falls from the cloud, if at all if it is not a flight, right, you call them as what? Precipitation. This is the last compartment of the cycle called as hydrological cycle. Right? If you ask me what are the different forms of precipitation, what are the different forms? Like in what this precipitation will be happening. Simple, right? What form it is going to fall? That's it. That's the question, right? In that case, if you ask me, the most commonest form of precipitation is what? Rainfall. Number one, it is rainfall, right? Now, my dear friends, within the meaning of rainfall, I'm also including drizzle, my friend, right? You ask me what is drizzle, I would say it is immature rain. Immature rainfall, you call them as what? Drizzle. Right? Immature rain. Falling of water droplets, I call them as what? Rainfall, my friend. On the other hand, when I talk about another form, my friend, I call them as snowfall. Correct. When I talk about snowfall, my friend, right? When I talk about the immature snowfall, I call them as what? Glaze. Right? Glaze is nothing but what? Partially molten snow, my friend. This partially molten snow, I call them as what? Glaze. Right? Then you call them as what? A sleet, my friend. Sleet. Sleet is nothing but what? Small ice crystals. Small ice crystals. Right? Then you call them as what? Rain. Rain is nothing but what? Small ice crystals. Sleet. Sleet is nothing but what? Small ice crystals. Right? Then you call them as what? Snow. Snow is nothing but what? Small ice crystals. You call them as what? Small ice crystals, my friend. Right? And then when I talk about number 4, I call them as what? Hail. Hail is large ice crystals. This is what I call them as what? Hail, my friend. Rainfall, snowfall, sleet and rain. Okay? Right. So what is what? Approximately we have an idea. Right. So somewhere I'll just tell you, I'll show you the types of this precipitation. You call them as the forms of precipitation. These are the 4 major forms of precipitation, my friend. Okay. You call them as rainfall, you call them as snowfall, you call them as hail, you call them as sleet. Okay. Just for your reference, how exactly they look like, right? See, sometimes what happens, if you add more information, it becomes a burden to you. Right. So what I do, you don't add more information to it. Right. That's the reason again and again I'm insisting on thing. This examination is for jack of all trades. Right. This examination is not for the masters. This examination is just for the jacks. Right. So if you really feel that okay, you are a jack, this examination is for you. Okay. I think this should be fine enough, right? 4 types of precipitation. Even you don't, I have taken it as a forms of precipitation. Okay. So here also I will change it, right? 4 forms of precipitation. Even they say 4 types of precipitation in our world. Okay, right. So rainfall, right? Snowfall, sleet, and hail. Right, my friends. Now, somewhere I have just talked about the forms of precipitation, what forms it is falling. And finally, my friend, I talk about the types of precipitation. Types of precipitation. See here, the earlier image, what I have given as what types of precipitation. See, small changes. Small meaning, let us not take it so seriously, because right, we don't have, right. Say for example, the fair usage of the words, my friend. Okay. Simply here, if possible, you can change it, right? Instead of types, you can remove the types. You can put it as what? Forms. Okay. Right. Somewhere I'm just getting forms of precipitation, right? What is the forms of precipitation, my friend? Whatever it is, just for the easiness of remember, I have just changed the name, no problem, right? Now coming to the final aspect, types of precipitation. See, when I talk about types of precipitation, what exactly is the process that facilitates this precipitation? Generally, there are 4 types. Most of the book says 3. What are they? I'll tell you. You call them as what? Orographic precipitation, frontal precipitation, and convectional precipitation. I tell you that what type of precipitation you will be experiencing. See, for example, along the mountainous region, my friend, right? Wherever, if you have, say, for example, mountains, am I right? When the air mass rises along the slope of the mountain, as and when this air mass rises, what happens is air mass will go for what? Condensation. Correct? And this air mass will result in what? Precipitation. Am I right? Such type of precipitation, my friend, call them as what? Orographic precipitation. Okay. Already we discussed about it. If you remember, we discussed about the descending air mass of the world. Am I right? Descending winds, like Chinook, Santa Ana, and so on. The concept we have taken. So the first type of precipitation, we call them as what? Orographic precipitation. See, rainfall is one form of precipitation. That's the reason I'm not calling it as what? Orographic rainfall. I'm calling it as what? Orographic precipitation. I am including the larger segment. Right? Okay. So, which side? Normally, the windward side of this mountain is experiencing this precipitation. Sometimes, orographic precipitation, my friend, it is also called as a relief precipitation. Very popularly, you call them as what? Relief rainfall. Right? Why it is called as a relief rainfall, if you ask me? That's a relief. It's a landform feature. Doing the same, the air mass is, say, for example, the rising, it is going for a condensation. That's it. What is orographic precipitation, my friend? Any precipitation which happens along the mountainous slope. Am I right? See? The windward and the leeward side, as we see. Oro means mountain, my friend. The same thing. We call them as what? Orographic precipitation. Correct. As I said, sometimes you also call them as what? Relief precipitation. Right. Right. Then what exactly is another types, if you ask me? In the middle latitude, my friend. Right. What you experience is a frontal precipitation. The second type of precipitation in mid latitudes, what you will be experiencing is a frontal precipitation. We call them as what? Front. Climatic front. What is a front? Maybe sometimes later on we discuss. Right? But I think by this time you might be knowing it, right? What is a front, if you ask me? See, at 60 degree, my friend, about frontal precipitation or frontal rainfall, they call them as. They call them as frontal rainfall. They call them as frontal precipitation. What is this frontal precipitation, my friend? 60 degree latitude is that latitude where two contrasting air mass will be converging with each other. Right? One side I'll be having a cold air mass, and one side I'll be having a warm air mass. Okay. Somewhere, everywhere you're finding it. What exactly you're finding it? One side I have a cold air mass, and one side I have a warm air mass. So what happens, my friend? When this warm air mass still tries to merge with the cold air mass, right? This air mass will start climbing over this front, right? And whenever air mass climbs over any front, my friend, at any front, I understand, right? This air mass will go for what? Condensation. And this air mass will result in what? Precipitation. Right? Somewhere I'll just copy one better image. So you're talking about the frontal precipitation. Somewhere 60 degree latitude is that latitude, my friend. Where exactly it happens, I'll tell you. Somewhere at 60 degree. Slightly, I'm just going to reverse the image. Okay. Somewhere around 60 degree, my friend. 60 degree latitude. So 60-degree latitude, both north and south, this is the place where I have subpolar low, my friend. The pressure belt called as subpolar low. Now this is the place where two contrasting air mass tries to converge with each other, my friend. From the polar region, what you experience, the wind, what comes from the polar region, is an extremely cold polar wind, my friend. And another wind which comes to this region, it's from the tropical region, right? This wind, we call them as what? Westerly wind. Okay. Even the temperature, we call them as what? Warm westerly. Am I right? See, in the adjoining image, what exactly you're seeing is the same. Right? Exactly between these two contrasting air mass, my friend, a clear-cut demarcation is formed. This clear-cut demarcation which is formed, which separates both these air mass, this is what you call them as what? Front. You call them as what? Front. So front is nothing but what? A boundary of an air mass, we call them as what? Front. Now, my dear friends, what happens? We know the fact that any warm air mass is always less in density, and they have a tendency in what? Right? Climbing over the cold air mass, my friend. But you know the fact, as and when the air mass rises, it goes for condensation, and this condensation results in what? Precipitation, my friend. Right? This is what you call them as what? Frontal precipitation. Right? You call them as what? Frontal precipitation. Okay. Throughout the year, this frontal region, mid-latitude, my friend, what you will be experiencing, right, is a precipitation. Throughout the year, correct? Throughout the year, my friend, what you will be experiencing is a frontal precipitation, right? Right. So what is orographic precipitation? What is frontal precipitation? Both we have taken it. And finally, the last type of precipitation, if you ask me, right? Last type of precipitation, we call them as what? Convectional precipitation. Okay. You call them as what? Convectional precipitation. See, what is convectional precipitation? Wherever you have a very warm condition, right? Wherever you have a warm condition, my friend, air mass rises on its own. When the air mass rises on its own, normally understanding says, right, that will go for what? Adiabatic cooling, right? This adiabatic cooling will be resulting in what? Condensation. And this condensation will be resulting in what? Precipitation, my friend. Right? So, wherever heat is very high, my friend, wherever the temperature is very high, on warm occasion or warm condition, my friend, warm conditions results in what? Convectional rain, or you call them as what? Convectional precipitation. Equatorial region, lower latitudinal summers, all these places, what you experience is what? Convectional precipitation. Right, my friend. So, three types of precipitation we have planet: orographic, mountain, frontal precipitation, mid latitudes, and convectional precipitation, warm regions. Correct? Right. So, everything we have taken it, my friend. So, one more diagram also I'll just copy for this convectional precipitation. Slightly you can understand it. This is a GIF image. You cannot copy it as a GIF image. Right, my friend. So there, all types of precipitation, all forms of precipitation, we are completing it. Now, my dear friends, with this, the remaining of the wind we have completed, and the broad topic called as hydrological cycle, that also we have completed, right, my friends? So there we'll end the class, right? And the next class, when we see, we'll discuss about some very important topics like cyclones, both tropical and temperate, and we'll also discuss about this mechanism called as monsoon. So thank you and God bless.